We can conclude our Matlab examples by obtaining the plot of the efficient frontier. So in our last demonstration, we have seen how to calculate an efficient portfolio on the frontier by considering this second problem here, that is minimization of the portfolio variance for a given target return. So this obtained portfolio from this optimization is on the frontier because for a given level of target return, it has the lowest variance. So now what we can do is we can change and we can consider a range of target returns, and we can solve the same problem repeatedly. And this way we can obtain the locus of all these points on the efficient frontier, and we can construct a plot of the expected returns and the variances of these of such portfolios basically. So how can we do this in Matlab? So what we want to do now is suppose we are given again some vector of expected returns. And suppose that in this example we have 4 assets. Okay, so you can see I have a vector, column vector 4 by 1 for the expected returns. I calculate what is the length of this. So I find out how many assets exist in my economy. And then I have somehow calculated from my data, let's say, what's the covariance matrix. Well, this should be 4 stocks, obviously, right? We have 4 stocks in this example. And basically then I'm going to change the target return on a grid. I'm going to define this range of target returns, let's say starting from 1% all the way to 20%, or you can slightly change this range, it's okay. And at every iteration, I want to increase my target return by 1%. Okay, so if you want more points on your efficient frontier, you can make this a finer grid. Okay, that's up to you. But that should be fine by going in increments of 1%. So what I need to do is at every iteration, I need to solve this minimization problem many times in order to get the combination of all these efficient frontier portfolios. And as we remember from our previous demonstration, basically first you need to define what's your coefficients matrix A, and then you have your right hand side of the problem, right? Remember from our representation. So basically we have seen that we can represent this as a system of linear equations. You can see we have on the right hand side we have the vector column vector of zeros, we have the target return, and we have a scalar which is 1, and which is exactly what we have written here. And then you can see we are solving this using the Gaussian elimination here. So we are applying the Gaussian elimination method here. And as we said before, you can also use the direct inversion, which is again fine for this small scale example. And then our optimal portfolio weights are given by the elements of this solution, but the last 2 terms should not be included because the last 2 terms, as you can see in the system, is lambda 1 and lambda 2. So these are the Lagrangian coefficients, which we don't need to use it here. So I'm excluding the last 2 terms, and the remaining terms are the optimal portfolio weights for this given target return. And the last 2 lines in my for loop here, what I do is to calculate what's the expected return of this portfolio, because now I calculated these optimal weights, W, and I can multiply with the vector of expected returns to get the expected return of this portfolio. And similarly, we can obtain what's the standard deviation of these portfolios, that we get the optimal weights. And once we are done with these, basically we can actually make a plot using our using the portfolio standard deviations on the x-axis, and we are going to put the expected returns of these efficient frontier portfolios on the y-axis. And additionally, we can also plot our initial portfolios. Okay, so if we run this much of our code here in this example, okay, let's run this one. Okay, so we can see the efficient frontier. You can notice that on the x-axis we have the standard deviation, on the y-axis we have the expected returns as given here, and you can see that these red dots, which are the given 4 assets that we started with, right? Because if you remember, we had these covariance matrix, and the diagonal terms of this original covariance matrix gives us the standard deviations of these 4 assets that we started with. So now, using the combination of these 4 assets, by finding these optimal weights, actually we can achieve these blue points, which are obviously better than these red individual assets, right? Because you can see, for example, for this given red point here, your standard deviation is like 0.4, and you can see that there is another blue point that corresponds to the same expected return, but it has much lower variance. So the locus of points, the upper part of this curve, is called as the efficient frontier.